Hello ladies and gentlemen. Okay, we're back. This is lesson 2.4. Select and apply factoring strategies. Okay, perfect square trinomials. Perfect square trinomials are not really any different than the trinomials that we've been working with, and I would rather not complicate methods trying to notice them and do them in a short, quick method. So I'm actually not going to worry about knowing if something is a perfect square trinomial. Instead, we're just going to factor them like I taught you earlier. So in this one, you'll notice that the a value is equal to 1. So this is what we call a simple trinomial. We put an x, we put an x. We look for two numbers that are going to give me a product of 9, and they're going to sum to -6. Well, that's going to be 3 and 3, as long as it's -3 and -3. So it's going to be -3 and -3. And what that gives us is x times x is x squared. -3x, -3x is -6x. -3 times -3 is +9. Now the reason why they call this a perfect square trinomial is because you see how the two factors are identical? Well, we can write them as that. Just the same way as if I told you that I had 5 times 5, we could write that as 5 squared. Well, or if I told you that I had x times x, then that could be x squared. Well, what I'm telling you now is I have x minus 3 times x minus 3, and we can write it as x minus 3 squared, which we call a perfect square trinomial. This trinomial is equal to the nice squared, and we say squared because it's to the exponent 2, binomial of x minus 3. That's it. So here's another one. The only difference is you'll notice that this a value is not equal to 1, and we can't common factor it out, so we're looking at using the seesaw method. So 25y over 25. Looking for two numbers that multiply to give 100. Because this is the seesaw method, we have to take the 25 times 4. And we want them to have a sum of 20. So two numbers, I think we can find that fairly easily. It's going to be plus 10 and plus 10. 10 times 10 is 100. So we get to put plus 10 here and plus 10 here. Remember, when you do perfect square trinomials, we want to be able to get rid of this, or not perfect squares, but seesaw. We need to be able to get rid of the number on the bottom. It's got to come out of the front. Don't take it from here or here. You got to make sure that you can common factor out of this binomial. And what's going to common factor out of a 25 and a 10 is a 5. And that'll leave you with 5y plus 2. We can take a 5 out of here, which is 5y plus 2 again, over top of 25. See this 5 here? See this 5 here? Those two 5s can go together to give me a 25. So it's going to be 25, 5y plus 2, 5y plus 2, all over 25. What we have now is this 5 multiplied to give this 25. This 25 and this 25 will now reduce, leaving you with 5y plus 2 and a 5y plus 2. You notice that these are identical, so that can be written as a perfect square trinomial as 5y plus 2 squared. That's it. Those are perfect square trinomials. Let's flip over and see what else we have going on. Okay, so this is a different type of factoring. This is called a difference of squares factoring. Okay, and it happens whenever you have one thing squared, subtract another thing squared. It has to be subtract. That's why it's called a difference of squares. There is no such thing as factoring a sum of squares. If that was a plus sign in between them, you could not do it. And the way that they factor is a squared minus b squared actually work out to be a minus b and a plus b. I know, it's pretty weird, but it does. Let's take a look at why. If I take a minus b and a plus b, and if I expand them, so these are the two factors, but if I expand them, a times a is a squared. A times b is plus ab. Negative b times a is negative ba, and b times b is going to be negative b squared. Now, a times b is the same as b times a. The order of multiplication doesn't matter. The first one is positive, the second one is negative, however. So if I've got 1a plus b, subtract 1a plus b, they're going to cancel each other out, leaving us with a squared minus b squared. What does that mean? Well, it means that a squared minus b squared, when factored, is a minus b, a plus b. Or, let's not worry about the order, because the order of multiplication doesn't matter. Okay, so let's see how that's going to work for us. Here's x squared minus 49. This is a difference of squares factoring. First of all, it's not a trinomial. There aren't three terms, there's only two terms. So, notice that this is x squared minus 7 squared. Now think about that for a minute. X squared is x squared, and 7 squared is 7 times 7, it is 49. Notice I've created a difference of two squares. X squared minus 7 squared. So the a is x, the b is 7. So it should be x minus 7 and x plus 7. And so I said them in the reverse order, but as we've said several times, it doesn't matter the order of multiplication. We can write those either way. Now let's see if it works. X times x is x squared. This will be a positive 7x. This will be a negative 7x. They reduce. I've got negative 7 times positive 7 is negative 49. It works. Here's another one, a little bit trickier though. It's 4k squared minus 25. So when I write them as a difference of squares, I have to be sure that I do 2k. Because when I square 2k times 2k, I get 4k. So this should be 2k minus 5 and 2k plus 5. It's really quite simple once you get the hang of it. Over here, difference of squares. The square here is 18u squared, so that has got to be, that's not a difference of squares. 18 is not a perfect square number. I cannot do this. So then what do? I try to common factor. Let's think about this. Is there anything that I can take out from both of these? The answer is yes, I can take a 2. That now has allowed this to become a difference of squares because 9 is a perfect square number and so is 1. It'll look like this. 3u squared minus 1 squared. This is now the difference of squares. This is a, this is b. Don't lose the 2, you still have to have it. So it's going to be 3u minus 1 and a 3u plus 1. Take some time to look at that. That'll make more sense. This one, this is a little bit different. This is a perfect square, 16. It's 4, and w squared squared will give me 16w to the 4. 81 is going to be 9 squared. So this is my a, this is my b. It's 4w squared minus 9 and 4w squared plus 9. That would be great, except there's still more we can do. This is still a difference of squares. This is a sum of squares. There's nothing we can do with this. But this one could be written as 2w squared minus 3 squared. This one, there's nothing we can do with this. But this is now A, this is now B, and it becomes 2w minus 3, 2w plus 3, and you can't forget about the 4w squared plus 9. So that one kept going. So let's be sure that we know, look for common factoring. And this one, look for more differences of squares. It keeps going. This one factors back down into another difference of squares. Okay, so let's see where we're going now. When factoring, you should follow these rules. You should always common factor first, yes. You should check for special patterns like difference of squares or perfect square trinomials, yes. And then you should use the product and sum or seesaw, yes. And you should always, always, always make sure you common factor first. I'm going to stop the video here, and then we'll do the last page of this lesson.